I just want to point out to you guys that if you looked at the My Notre Dame and you looked under links, you'll see this is the video from last class. So that's where the videos are going to go. They're going to be in the links file or under the links section. And I'll just label it as the date that we did it. And then, like a list of, some stuff that we did. Here, this list was a little bit more detailed because it wasn't like a section from the book. It was just, a list of things that we did. Okay? So that's what that'll look like. I figured I'd just point it out to you since we actually have something to show you today. And if you went and looked in the content library, here's the notes that we wrote. Right? All right. Today, we're going to pick up where we had left off and kind of continue doing some geometry review. And then after a little bit of that, we're going to do our first Delta Math assignment. We're going to do that here in class so that we remove the figuring out the technology at home on your own part, so that if something's not working right or we can't figure it out, we can take care of that together. And I just have to try to get my pen to work again because it's being stubborn here. Okay, there we go.
Are we going to need a calculator today?
Yeah.
Do you have one to borrow?
Yeah. I do have a few that are available to borrow. Yep, we'll cross that bridge when we get to it. Okay? You're welcome. Worst case scenario, you can share with a neighbor. It's not the end of the world. Right? We'll probably have enough between the 20 of us to minimize the amount of that it would have to have. All right. So last time we had been talking about some of the geometry skills that we had dealt with a long time ago back in our geometry class that would be kind of foundational skills to what we're going to be starting to do. We had kind of gone through and talked about all the topics. What I wanted to do is spend a little bit of time and do some example problems to kind of refresh how to do that kind of work. And then the things that you're going to be doing in Delta Math today as your practice will be similar to these things that we're going to be reviewing right now. Okay? All right. All right. So let's say we have a right triangle here. And actually, Mr. Kulik will name these vertices just so it's easier for us to talk about it. So we have this right triangle here, ABC. We're told that angle A is 46 degrees, and side CB is X, and side AB is 12, and we're asked to solve for X. This should look like a familiar kind of geometry-ish problem, right? Probably did a lot of these. what am I going to be using to solve for x in a problem like this? What's going to be my main geometry tool that I'll use? Sohcahtoa, right? If I have a right triangle and an angle and a side, I'm going to be using sine, cosine, or tangent, right? So the question becomes, okay, I know I'm going to be using sine, cosine, or tangent. Which one of those three do I want to use in this case? Yeah, so Nathan, you say sine?
Yes.
That is correct. How did you come up with that?
Well, I looked at it and I see the opposite angle. We have the hypotenuse.
So relative to the angle that's given, we're looking for the opposite side, and we're given the hypotenuse. And we remember that sine is opposite over hypotenuse. So that's how Nathan was able to come up with that. So we'll write sine of, what's going to go inside the sine? 12, 46, or x? Not x. It's the 46, right? The angle measure is the part that's inside a sine, cosine, or tangent, right? Sine, cosine, and tangent operate on angle measures. And then the opposite was x, and the hypotenuse was 12. So the geometry part's now over, right? What we have now is an equation. So if I want to solve this equation for x to get the x by itself, what's the first thing I should do?
Multiply both sides by 12 over 1.
Great. We'll multiply both sides by 12 over 1. I'm just going to write it as 12 because it's the same thing, right? That's going to cancel with the 12 in the denominator. So I can say, okay, x is equal to 12 times sine 46. What do I do at this point? It's calculator time, right? So I'm going to go and pull up my calculator. What do I need to be careful about before I start typing this into my calculator? What do I need to be?
Degree?
I do need to make sure it's in degree mode, yes. Whenever I'm using sine, cosine, or tangent, the mode of my calculator has to match the measurement on my angle. In this case, we're using degrees on our angle. How do I know that? The symbol was written right next to the 46, right? Now, I don't know, did you guys talk about radians in your geometry class? No, okay. So we won't see radians then in this course until we talk about it in this course. So until that point, there's no question. Everything is in degrees until we start talking about radians, and then we have to be a little bit more careful. Does anybody remember how to change from radians to degrees in your calculator?
Mode.
Great. You press the mode button right next to the blue second button, and the third option should be set on degrees. If it's not, just use the arrows on your calculator to move your cursor so that it's on degrees, and then press enter. Those of you that borrowed a calculator from me, you probably have to do that because it was probably in radians. Good. Okay. Hi again. Patrick. You're welcome. All right. So to type this into my calculator, I'll just type 12. I'll type my time symbol. The sine button is right here, kind of 2 buttons up from the 7. And then I'll type the 46 and close my parenthesis and press enter.
I got an error.
Okay. What does the error say?
Domain.
Okay. So I think you probably did sine inverse rather than sine. Is there a little -1 next to your sine? So that was the issue. You pressed the second button before you pressed sine. So just try typing it again with, good. Anybody else with an issue? Great. So if we wanted an answer rounded to the hundredths, what would I write? 8.63. Excellent. So again, I'm writing notes for you guys, so I'm putting in like, I noted that I used my calculator here. And why did Mr. Kulik elect to use squiggly instead of a straight equal sign? It's because we rounded. So whenever I do any rounding, I try to make sure I remember to put the squiggles. I'm not going to be picky about that for you guys, but these are my notes, and I'm trying to be consistent and accurate about what it is, that x isn't exactly 8.63. It's rounded to about 8.63. Okay? Cool. Let's do another. Yes?
Yes.
Okay. And we'll do, I don't know, 5 or 6 of these kinds of things, and then we'll fire up the delta math, because if I recall, I did this several days ago when I made this assignment. But it's all kind of these-ish problems. Well, that doesn't even make any sense. So we have a right triangle ABC, and we're told that angle B is 27 degrees, side CB is 8, and side AC is X. We're trying to solve for X here. Okay. So same kind of setup as before. We have an angle and a side. So I should use? Great. And how did you arrive at tangent? Great. So relative to the angle that's given, we have an opposite and we have adjacent that we're interested in or that we know stuff about. So we're going to say tangent. Great. So I'll write tangent of what goes inside the tangent? 27. Great. And equals, which one was the opposite? And the adjacent is 8. Okay. Everybody feel good? Okay. And now it's just algebra from here. So to get the x by itself, we multiply by 8. Mm-hmm. And we just go to our calculator, type it in just like we see. Notice that the tangent is like 2 buttons above the 9. And if we round to the hundredth, we would write 4.08. Oops. Chahtoa.
No, it's just like
Yeah, it's okay, dude. It's all right.
Oh gosh. Oh man, that's a little. It's been 3 months. Oh, 3 months. What is that? What is that? She said, "Oh, Sophia."
All right. So again, same kind of setup. Oh my goodness here. What was I doing? What was wrong with what I just did?
We did.
There's no x, yeah. It'd be like it's the shortest problem ever.
It's like a blue mistake.
All right. So same kind of setup, right?
Yeah. And not the exact same, but.
Yeah. We got an angle, we got a side, we're looking for another side, though, inside of a right triangle. Okay?
Oh, we got ka.
Good. So I agree. So we're going to use cosine. I'm going to skip explaining why. Is everybody okay? It seems like we've kind of feel pretty comfortable doing that. Good. Okay, cosine of 48 equals 7 over x. Great. Okay. Now it's algebra time. What do I need to do to get the x by itself? Great. We have to multiply both sides by x, right? If you multiply by 1 over 7, you're going to end up with 1 over x on the right side, which is not what we're looking for. We want just x. So when x is in the denominator like that, the first order of business is just to multiply it to the other side. So we get it out of the denominator. No more fractions. Is everybody cool with that? Okay. So that's going to give us x times cosine of 48 equals 7. Okay, what do I do next? Divide by?
No, cosine 48.
Cosine 48. Remember, cosine 48 is just a number, right? If you type that into your calculator, just a crazy decimal. So all we're doing is dividing by that crazy decimal. I'm just going to, instead of writing the crazy decimal in all its crazy decimal places, I'm just going to write it as cosine 48 because the calculator will handle all the crazy decimals for me. Because x was in the denominator, so the first order of business would be to get rid of the x in the denominator. If I multiplied it in both sides by x, we move the x into the numerator of the fraction. Right, so this is like over, oops.
Is that what we did for all of them?
No, but if you look in the other ones, the x was in the numerator of the fraction already. So this problem was different in that the x was in the denominator. Does that feel better?
It needs to be in the top shelf.
Yeah, it needs to be in the top shelf to work on it. Way to go. All right. So this is where we're at, right? We feel okay? Okay.
Wait, so why is it 7 over x? Because that's what a lot of ask the question.
Okay. So,
Because the cosine is adjacent over.
Okay, that makes sense.
yeah, adjacent over hypotenuse.
So that's all I needed.
Yeah, good.
The hypotenuse is x, and the adjacent is 7. So then it goes 7 over x.
It just gotta be on top.
So, yeah,
Yeah.
if you're solving for x, you need the x in the numerator. Okay. All right. So to type this into our calculator, I'm going to show you guys a nice option that allows you to type into your calculator exactly the way it looks like on your sheet of paper, which I think is often quite helpful for students. So if you press the alpha key, that's the green one, and then the y equals, there's not a beta key. This opens up the fraction shortcut, or a shortcut to the fractions menu. If you're writing a vertical fraction like we've written here, we'll just always pick the option 1. And that's going to put us a fraction on our calculator. I press the alpha key and then the y equals and pick the first option. If you have an older calculator, you might not have that option.
When I hit alpha and y equals, it just goes to that.
Yeah, so let me look here. Yeah, so yours has just got the older operating system that doesn't have the math type on it. So you're just gonna have to write it as a.
And what's the other thing we did for the alpha last class?
It's probably the same thing.
Oh, okay.
Okay.
Put the parentheses. And then
So that allows me then to type this in exactly as it looks on my sheet of paper and press enter. So if I wanted this rounded to the 100th, I'd write 10.46. And my pen has stopped working again.
she was mocking me. She's taking on your assets.
All right.
So is it just 10.4? Yeah.
Yeah, X is approximately, yes. My pen stopped working and I wanted to,
I heard uncle.
Can I borrow someone's stylus for a few minutes here? Yeah.
Maddie has a really good one.
Is anyone not using theirs that I can borrow for?
Oh, I am using it.
Oh.
But you can borrow it. Is it going to be a...
I mean, I want to borrow it.
Okay.
Thank you. I'll return this to you. I think the battery died on it and it's just being stubborn.
What happened to my wallet?
Thanks.
Okay. What do we notice here?
Oh, we got
There's no,
the angle. We don't got an angle.
This time we're solving for the angle.
That's something.
Now, does this fundamentally change the way we start the problem?
No, probably not.
No. We're still going to be using Sohcahtoa. So which one would I want to use in this case?
Opposite and hypotenuse.
So relative to the angle in question, we have opposite and we have hypotenuse. So we do want to do sine. So I'd write sine of x, very good, is equal to 7 over 10. So far, so good. Okay. So next stop is to get the x by itself, right? So to do that, I have to get rid of the sign that's in front of it. Everybody agree?
Yeah.
How do I do that? Not multiplication. Yes, so I need to use sine inverse is the name of that one.
Oh, is that the -1?
That's the -1. So to do that, I'm going to do sine inverse to both sides of my equation. So I need to move that up a little bit. Does everybody feel okay with what I did here? So why did I do this?
Yeah, but
because sine inverse cancels the sine, and that's going to get
X by itself.
the x by itself. Does everybody feel still doing okay? All right. So now it's calculator time. So to get the sine inverse, how do I get that on my calculator?
Second sign.
Second, and then the sine button. Very good.
Back to your calculator where it says the same thing.
Do you do that fraction thing?
You can if you'd like. So I could do alpha y equals, and then pick the first option to do 7 over 10. So what should I write here if I want this rounded to the 100th?
44.43.
44.43. Very good.
Yes.
I was thinking the negative ones.
Yep. Just part of the name of that function.
She can't.
Everybody's okay here? Okay.
Yeah.
That's an issue. Nah, I'm just like.
Okay. Here's our next one. No. No.
We don't even have an angle.
No.
Okay.
Because there's nothing inside of it. There's nothing on the
We
inside.
gotta do something on the outside, not the inside.
We make our own angle because we know it's 90.
No.
So you subtract 90 by
No. Easier than all of these things you're suggesting. It is the Pythagorean Theorem, right? If you have two sides of a right triangle and you're looking for the third,
That ain't my job.
it's just the Pythagorean Theorem. We don't need Sohcahtoa, right? Is everybody okay? All right. So what's the Pythagorean Theorem again?
A squared plus b squared equals c squared.
Okay. What value do I have to be careful about plugging in, A, B, or C? C. C has to be 13, the hypotenuse. Does it matter whether the X is the A or the B?
No.
Nah, man.
Nah, man. I don't think you chill with it.
Boy, I know you're chilling.
Okay. 7 squared is 49. 13 squared is 169. Just as a separate aside, is 13 squared minus 7 squared just 6 squared? No. Why can't you do that?
Messes it all up because of the square.
It-
Two numbers in complex.
So it's the order of operations. What has to happen before?
Before you can add or subtract.
Exponent.
You have to do the exponents before you could add or subtract. Good. Is everybody still okay?
Yeah.
Okay. So we'll subtract. Well, or I'm sorry, what do I do next?
Minus the 49 on the square.
Okay. So again, we're doing that to both sides of the equation. So on each side of the equals. Okay. So that's x squared equals 120. What do we need to do next?
Square root.
Square root.
Right.
Good. So if I want an approximate answer, I can just type this into my calculator, right? So to get the square root symbol, I'm going to press second, and then the x squared button. That's like 4 below the blue one. So 10.95, yep. But what if I wanted an exact answer?
Oh, I know.
Exact answer, we're gonna have to do some.
I like algebra.
And let's say with reduced radicals.
Oh.
So that's radical. This is my specialty.
Okay? So let's review how to do this. Sound good? What is the key to doing this is we're looking for what kind of factors of 120? Perfect squares.
This is my
So give me an example of a perfect square. What? So 100 is a perfect square because the square root of 100 is 10. Great. What are some other perfect squares? 49, 64, 4, 9, 2 is not.
Oh, no, it's not. 1 is 16.
16 is. Right. So we've named a bunch now, right?
25.
What's 25 is? What's one? Are any of those a divisor of 120? Other than 1.
Oh, yeah, you can get a 5.
10 isn't a perfect square though, right? 4 is a perfect square. 10 isn't a perfect square because the square root of 10 isn't a whole number. But 4 is, right? So we can rewrite the square root of 120 as the square root of 4 times 30, right? How does that help us? Because we can break a radical at a multiplication or division symbol and write that now as the square root of 4 times the square root of 30. And we know what the square root of 4 is. That is 2. Okay. Now let's look at the square root of 30. Are there any perfect squares in that? 6 isn't a perfect square. 3 is not a perfect square.
No.
There are no perfect squares in that.
Break it apart.
You could, but we don't need to because there are no more radicals to reduce if there's no more perfect squares in that number. So we'd be done.
You just leave it.
So it would be finished here. This is your exact answer with reduced radicals.
Huh?
Okay. Should we run through what we did there one more time? Just to kind of talk through it in real time as to what we did.
I would love that.
Yeah.
Okay.
Big fan of real time.
So we were asked to rewrite the square root of 120 with reduced radicals. So what we wanted to do was see if there were any perfect squares that were factors of 120. So your perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Are they your first 10 perfect squares? The number that we saw that divides 120 is 4. Sometimes there's more than one. That's okay if there is. You can just do it one at a time. The good news about this is that each time you find a perfect square, finding the next one's going to be easier because the number left over gets smaller, right? So that's what we did. So we rewrite 120 as the square root of 4 times 30. And then we know that we can break a multiplication symbol at multiplication, or break a square root at multiplication or division. That's the only places you can break it, not at addition and subtraction though. Be careful about that. So I rewrote that as square root of 4 times the square root of 30. And the square root of 4 is a perfect square. That was easy. That's just 2. And because no other numbers from my list of perfect squares divide 30, other than 1, which is trivial, right? Because 1 is just 1 squared. And I can, okay, so then I have 2 times 1 times square root of 30. Still just 2 times square root of 30. Since 4, 9, 16, 25, all obviously don't divide the square root of 30, we knew we were done. That's okay? All right. So I think on occasion in the delta math problems they ask for an answer with a reduced radical. So, all right. How do you guys feel so far?